problems that don't involve calculus. Now, I'm going to go ahead and write down the domain of this expression. In my inspection, you can see it's going to be minus square root of 5, square root of 7, excuse me, minus square root of 7 inclusive, and then square root of 7. Okay, that's the set of permissible x values here. Now, again, not necessary, but it's kind of useful. This is only good as its weakest link. This one here has domain all real numbers, right? But right here, you can't stray to the left of minus root 7 or to the right of plus root 7. Otherwise, you have a negative radicand. Now, the Cauchy Schwarz inequality it fits perfectly. If you take a look at this, you can just think of a sub 1 being 4 and b sub 1 being this radical expression. And the Cauchy Schwarz holds for all real numbers, all complex numbers, so there's no constraints on the variables. You can think of it as just two sequences, a sub n, b sub n if you want to. Now, and again, it goes very, very straightforward. It's just a straight handoff. This almost lines up perfectly. A1 is 4, B1 is square root of 7 minus x squared, and similarly for A2 and B2. And this is the right-hand side of the equality. Everything fits nicely. I took the trouble to square the relevant objects right here, 4 squared and 9 squared. Then also notice when you square the b's, it just removes the radicals. Or the radicand here is 7 minus x squared. When it gets squared, all that's left is 7 minus x squared. And after you do all the arithmetic, you get this statement right here. Now you may wonder where this comes from. Just right over here, you can rewrite this piece right here as 97, square root of 97 times 2, 97 times 2 times 9. There you go, 97 times 2 times 9, and that explains 2 times 97, of course, is this 194 you see right here. And then the square root of 9 is the 3 that you see right here. So this is the answer right here. This is the maximum value. Now we can actually, so we're done with the problem as far as what was asked. This is the maximum value of this function. And so, I mean, again, we've completed the problem as far as what the instructions go for. But the equality condition is a fairly easy thing to determine here. Equality happens exactly when these sequences, if you want to think of them like that, or coordinates of a vector are proportional. So that means when a sub 1 over b sub 1 is equal to, just all the way across, we just have, we're just in 2 space right now, so, but this would have to equal to a sub 2 over b sub 2. A sub 2 over b sub 2, and they're all equal to just some constant, okay? So that's, again, what does this mean? This is when the equality part holds. Or if this happens, if the sequences enjoy this property, then it's not just less than, it's directly equal to the equality part right here. And so that's how you figure out where the equality happens. You see, what we do is we just, again, exactly according to this convention here, or this truth, it's a provable result, and the proof's not that hard, that equality happens when these ratios are equal to each other. If you square both sides and cross multiply, you end up with this statement right here. And then when you divide by 97 and take the plus and minus square roots, you get x is equal to plus or minus the square root of 391 over 97. So we got 391 here as the numerator of the fraction over 97. Now notice, folks, that we did mention the domain of this function a moment ago. And the domain, if you recall, the domain is the square root of negative 7, square root of 7 are the permissible values of x. That would include 0, of course. Now, so notice here that 391, I'll just write it, 391 over 97 is somewhere between, what, 4 and 5, I think. But what's really important here is this number. And it automatically works out. You probably don't really need to verify this, but it's less than 7, right? And since it's inside this radical, that means 390, this value is contained in the domain. In other words, this is a member. Do we have room here? This is a member of the domain, if we have room to write that. That's a member of the domain. Domain of the expression. And I never even I called it that, but I didn't write it down. This object right up, this closed interval here is the domain. Okay. So again, I think it's kind of cool to see these things, although again, not necessary if you're just trying to answer a question in a math competition. All right. So again, the function maximizes at this circled value. Hope you enjoyed.